Okay, for this question, we are given y equals x squared plus 5 to the 11th times sine squared of 3x divided by the square root of x. We want to find dy dx using logarithmic differentiation. So I'm going to take the natural log of both sides. Natural log of y equals natural log of all of this. And I'm going to rewrite sine squared 3x is sine 3x squared. And I'm going to rewrite square root of x is x to the 1/2 power. Just so I can appeal to my rule of logs. We know the log of the quotient is the difference of the logs. So the log of the top minus log of the bottom. Log of the top, x squared plus 5 to the 11th. Sine 3x squared, that's log of the top minus log of the bottom. And then we know the sum of the log of the product is of sum of the logs. Then I can rewrite this as natural log y is natural log x squared plus 5 to the 11th plus natural log sine 3x squared minus natural log x to the 1/2. And then we can pull down the exponents. That's 11 natural log x squared plus 5 plus 2 times natural log sine 3x minus 1/2 natural log of x. So at this point, we want to go ahead and take the derivative with respect to x of both sides. So the derivative with respect to x of log x, log y, and derivatives of all three of those pieces on the right side. So here we go. Derivative with respect to x of natural log x equals the derivative with respect to x of 11 times natural log x squared plus 5 plus the derivative with respect to x of twice the natural log of sine 3x minus the derivative of 1/2 natural log x. Okay, well, the left-hand side was log y. I think I made a copying error there. So let's fix that. Left-hand side is log y. It's kind of an important mistake. Glad I caught it. Okay, so where do we go from there? The derivative with respect to x of natural log y is 1 over y dy dx. Here I'm going to pull out the constants, pull the 11 out in front of the derivative operator. 11 times the derivative with respect to x of the natural log of x squared plus 5 plus 2 times the derivative of the natural log of sine 3x minus 1/2 times the derivative of natural log x. So over here again, 1 over y dy dx equals 11 times the derivative of natural log 1 of something is 1 over the something. So 1 over x squared plus 5 times the derivative with respect to x of x squared plus 5 plus 2 times the derivative of log of sine 3x is 1 over sine 3x times the derivative of sine 3x minus 1/2 the derivative of natural log x is just 1 over x. Next, 1 over y dy dx equals 11 times 1, 11 over x squared plus 5 times the derivative of x squared plus 5, which is 2x, plus 2 over sine 3x the derivative of sine 3x, derivative of sine of something is cos of something. So cos of 3x times the derivative of 3x. And 1 over 2 times 1 over x is 1 over 2x. Next, 1 over y dy dx equals 22x over x squared plus 5. Plus, now we have 2 cos 3x upstairs over sine 3x times the derivative of 3x is 3 minus 1 over 2x. Now we have 1 over y dy dx equals 22x x squared plus 5 plus 3 times 2 is 6 cos 3x over sine 3x minus 1 over 2x. Well, cos 3x over sine 3x is cotangent 3x, so I guess that would make sense to rewrite it. So let's do that. So now we are going to say 1 over y dy dx equals 22x over x squared plus 5 plus 6 cotangent 3x minus 1 over 2x. Now let's multiply both sides by y. dy dx equals y times all of this, 22x over x squared plus 5 plus 6 cotangent 3x minus 1 over 2x. And what was y? What was y? Well, y was x squared plus 5 to the 11th times sine squared of 3x over the square root of x. Let's write all that out. X squared plus 5 to the 11th times sine squared of 3x over the square root of x, all multiplied by this, which I certainly do not want to simplify. 22x over x squared plus 5 plus 6 cotangent 3x minus 1 over 2x.